Okay, next we're going to take a look at ellipses. So the first question here, it says to find the center and radius of a circle. So this is actually just a review question. Again, I told you the new format we're going to see will be either like a review or some sort of prerequisite to help us get ready for this section. So I know that it's a circle because it's in that form, x minus h squared plus y minus k squared equals r squared. I don't have the fractions and the equal to 1 like you kind of see over on question 3, which is what makes up an ellipse. So that's how I know it looks more like a circle. So this is shifting to the right 4 because it's right next to x, so that's left and right movement, and it's opposite of what you think. The plus 3 is next to y, so that's up and down, and it's going to go the opposite, you think, down 3. And so that's going to be center of 4, negative 3. And then the radius, well, our r squared equals 81. So if r squared equals 81, then that means r equals the square root of 81, but that's just 9. So we have 9 is our radius. Number 2 asks, what are all the key features of the ellipse? So the main features that we've been looking at, says there's a hint that there's 4. Well, normally we want to find the center because I'm thinking about how do I graph it. I need to know the center. I need to know how much to go left and right and up and down. So those are always called the vertices if it's on the minor axis. Or, oops, not minor, that's the major axis one. Erase all that. So the major axis. And then there are the endpoints of the minor axis. Those are on the minor axis. Sometimes they're called covertices, so just a word that you might see or hear me say, covertices. So we have 3 things. What's the other thing? Foci. So remember the way that the ellipse is formed is by touching those foci. It's those distance, that equal distance to any point on the ellipse. It's formed by that distance. So that blue line is the distance to any point. So if I have another point on my ellipse, it must be exactly the same length if I add those 2 segments together all around the ellipse, and that's what helps form it. So just a reminder about that. So those are the main 4 things that you want to be able to find. Okay, so now we're going to actually look at an ellipse. So we have an equation here on number 3, and we want to be able to find those key features that we just talked about and also graph it. So the first thing that we're going to find is our center. Oops, wrong one. Oops, let's erase that. Okay, so the center, again, that's right next to my x and next to my y. That's how much we're moving left and right. Because normally it's at 0, 0 unless it has this shifting going on. So we're going to go to the right 1 and we're going to go down 6, just like our normal transformation. So right 1 and then down 6 would put a center at 1, negative 6. So I'm going to sketch that, 1, negative 6. And so we have our center here. And my graph's probably a little too small for this. All right, let's see what else we know. The number underneath the x is how much we go left and right, and it's the square root of that number. So square root of 25 will be 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then underneath the y is a 16. So that's going to be how much we go up and down. And so that's, again, the square root of 16, which is 4. And I am going to be off my graph. 1, 2, 3, 4. 1, 2, 3, 4. Sorry about that. And so our major axis is going to be horizontal. This is our major axis. And so that means that those guys are going to be my vertices. And the other guys are the endpoints of the minor axis. And I'm going to sketch the actual ellipse by just connecting those dots as best I can, and it looks kind of like a stretched out circle or like an oval. And then the other part I need to find is a foci. So let's actually identify what those points are. So the vertices, again, you could just think about how from the center you move to get to the vertices. We went left and right 5. That's the bigger distance, so that's why they're called the vertices. So left and right affects x. So I'm going to take 1 plus the 5, 1 minus the 5, so that's going to be 6, negative 6, and negative 4, negative 6. So those are the vertices, and you could check the coordinates. 4. So this is at -4, -6, and 1, 2, 3, 4, 5, 6. Just to verify, that's at 6, -6. And then the endpoints, again, thinking from the center, what did we do? We went up and down 4. And they are the endpoints of the minor axis. I guess I could write that. So that's just really plus the 4 minus the 4 to that -6. So we're going to be at 1. -6 plus 4 will be at -2. And then -6 minus 4 will be at -10. And that's why it's way off my graph. So those are going to be those endpoints. And then the last thing to find is the foci. And so the relationship between the foci was that distance to the foci, called C, is always your big guy squared minus your little guy squared. So in our case, that's going to be 25 minus 16, which is 9. So we get that C is 3. So again, they have to be on that minor axis. So I'm going to go left and right 3 spaces. There's one focus, and then 1, 2, 3. There's my other focus. So if I want to write the points for that, again, I always like to think about, I started at my center and I went left and right 3, because that's again where my major axis, the big axis, was. So that's plus the 3 minus the 3 to the x's. So I'm at 4, -6 now, and 1 minus 3 will be -2, -6. Those are my foci. Okay, looking at number 4. Now this one looks much different, but that's just because it's written in our more general form, and we want to write it in the standard form, the one that makes it easier for us to graph. And so we're going to have to do that completing the square. So I'm going to rewrite it so my x's are near each other, and my y's are near each other, and then I'm just going to let 177 hang out, and I have 0. So when I look at these first two, a little bit different is this 3. We want to pull that out first. So we're going to have x squared plus 4x. Then we're going to add the thing to complete the square. Make it factor into the pretty part. Same thing with the y's. They have a 5 in common. So we're going to look at taking a positive 5 out. We'll be left with y squared minus 12y. We'll add something, minus something, and then we still have 177. Do that in a different color here. 177 equal to 0, hanging out. So the thing that we're going to add to complete the square here, looking at 4, it'll be half of 4, which is 2, and we're going to square the 2. And so that's 4 minus 4. Do the same thing here. We're going to take -12, divide by 2, that's -6. So then -6 squared, that's 36 minus 36. So the whole reason in doing that was so the first 3 terms here will factor to that nice quantity squared where there's an x here. And we're going to put 2 because 2 times 2 makes the 4. 3 still hanging out. Then with my y's, again, taking just the first 3, that'll factor to y minus 6 this time. 6 times 6 is 36, and we need the -12. We'll still have the 5. And then I'm still going to have the 177 equals 0. But I noticed I forgot something. What about the 4 and the 36? Well, they have to be in there somewhere. And actually, they're both getting kicked out of the parenthesis. So if I take 3 times -4, I'm going to insert it right in here. That's -12. And I'm going to take 5 times -36 because they're getting kicked out. 5 times -36, well, that will put a -180 there. So if I look at combining just these numbers, -12 and the -180 and the 177, it ends up being -15. So I have 3 times x plus 2 squared plus 5 times y minus 6 squared minus 15. Now that's almost looking like my ellipse, almost. It's got the 2 things squared, but it doesn't equal 1. And there's some numbers sitting in the front. So I'm going to move the 15 over by adding 15. So I have 3 times x plus 2 squared plus 5 times y minus 6 squared equals 15. Then I'm going to divide everything by 15. and that becomes x plus 2 squared over 5, because 3 and 15 reduces to 1/5. Then it will be plus y minus 6 squared over 3, because 5 and 15 reduces to 1/3, equal to 1. Now I have my nice form for my ellipse. This is the standard form. Now I'm out of room in this little box here, but it wanted me to also identify the key features. So I don't have to graph, but I have to identify them. So just looking at it, we can identify our center. That's looking at plus 2, that's going to move left 2. Minus 6, that's going to move up 6. So really we could just write a positive 6. And so we have our center. We also know that we're going to move left and right, not 5, but the square root of 5. And that doesn't come out, so we're going to just leave it as that number. And we don't have to graph it, but we can think about what's happening. That's going to affect our x value here. It's going to add the radical 5, and then it's going to minus the radical 5. So a fast way to write the vertices, and the reason I know that these will be the vertices and not the endpoints of the minor axis, is because 5 was the smaller of the two numbers. So I know that the 3 is going to affect the minor axis because that's the smaller of these two numbers, and 5 will affect the vertices. So I'm going to write negative 2 plus radical 5, comma 6, and negative 2 minus radical 5, comma 6. For the endpoints of the minor axis, that's under the y, so it's going to go up and down. And the y is not always the minor axis, it just so happens that we're putting the small number was here. So square root of 3, again, that doesn't simplify, it's just square root of 3. So now that's going to take that same center, so if I'm thinking about this negative 2, 6, but it's going to take that 3, radical 3, and add it to the y. It's going to plus it, and it's going to minus it. So that would look like negative 2 comma, we'll have 6 plus a radical 3, and negative 2 comma 6 minus the radical 3. Again, we're not graphing, so we don't have to simplify those. We'll just keep them as those exact values. So then the last thing I need to do, that fourth detail, was to find the foci. And that's equal to c squared equals a squared minus b squared, but what I've been calling it is the big squared minus the little squared. Or the big guy minus little guy. So here that's going to be just 5, because we're taking really square root of 5 squared, and then minus 3, which is really square root of 3 squared, which is going to be 2. So that means that c will equal the square root of 2. And the foci are always on the major axis, and so I'm going to look at them affecting my x's, since that was my major axis, since it was bigger. 5 is bigger. So they're going to take that center, negative 2, 6, and it's going to add radical 2 and minus radical 2. So then my foci will be negative 2 plus the radical 2. The y doesn't change, just moving left and right, and negative 2 minus the square root of 2. So I have my foci, I have my vertices, my endpoints of my minor axis, and my center. Okay, we're going to move over to the back page, which starts with number 5, and it wants us to write a standard form of an equation in standard form. Write the standard form of an equation of an ellipse in standard form, subject to the given conditions. Okay, so really one standard form, the pretty form. And so it tells us our vertices and our foci. So our goal is to write something that looks, I always kind of start with writing it like a circle, but then I'm like, wait, it's an ellipse, so I'll make it equal 1, and then I know that these are over like some number, some number squared, and this is over some number squared. Okay, so I'm going to plot the points just to kind of help me out. So it doesn't say to graph, but I always graph so I can see what's really happening. So it says my vertexes, or my vertices are at 4, 0, 1, 2, 3, 4. So there's a vertex, and negative 4, 0. So like right away, I know that the center has to be 0, 0, because that's right in the middle between my two vertices. So I know also that I just went over 4 spaces to get to my vertice. And they're my vertices, so those are on the major axis, which keeps happening to be my x's. Again, it's not always. So I know that my h and my k are just 0, so I don't really need those. I know that I went left and right 4, so I'll have 4 squared here, so that's going to be 16. But I need to figure out a little bit more. So let's see. My foci, which aren't really in my equation anywhere, but they should help me, will be going left and right 3. So there's a focus, and there's my other focus. Well, the reason why the foci are going to help me is because the foci distance, that c, has a relationship that if you take c squared equals the big guy minus the little guy. So in this case, our big guy, and you can write as big guy squared or big guy, but really it wants that squared number. So we're going to have 16 minus, I don't know what that little guy is. I'll call that the b squared. So sometimes you see a squared minus b squared. And then c squared I know, because this distance I just went was 3, so 3 left and right, that's 3 squared, that's 9. So I have 9 equals 16 minus b squared. So then I'm going to subtract 16, so I get negative 7 equals negative b squared. So b squared is 7. So then I could just take this number, it's already been squared, I know it's not a perfect square, but it's already been squared, and just write 7 here. Or if you actually solve, you'd write radical 7, and it wants you to take radical 7 and square it. So my equation will be x squared over 16 plus y squared over 7 equal to 1. And what I like to do often if I'm asked to write an equation is like verify by like regraphing it to see if all those details end up showing up there. So again, didn't want me to graph the whole thing, but I could do that as a double check for myself. Okay, for number 6 and 7, they want us to look at some differences, and number 7 wants us to find some similarities between the graphs and the equations. So when I look at this one right away, I notice that all the numbers and everything is exactly the same, except that I have these power 2. That right away is telling me that I have an ellipse or a circle. When I look at the equation on the right side, there's just x and y only. This is just going to be an equation of a line. When there's just x's and y's, I mean, we can rearrange it if you really like y equals mx plus b. But if you start to plug in points, if you want to do it that way or find intercepts, you're going to form a line. That's a linear equation. And that's, I know that just looking at it because it doesn't have any powers, cube roots, cubes, anything like that. Again, we've been talking about circles and ellipses, and those are always happening when we have x squared and y squared. So it's either an ellipse or a circle. I'd have to play around with it to write it in our nice form to see. So then the next question, number 7, what similarities and differences? So just looking at them, if I'm thinking about the differences, I know that the first equation, well, it says equal to 1, and this one is equal to 9. So at first glance, the first equation looks more like an ellipse, and the second equation looks more like our circle equations that we've had. But then I also notice that these numbers are the same. So if I were to think about the graph, I would go left and right, up and down the square root of 9, which is 3, so I'd have some center, which actually that's something they have in common also. They have in common that they are centered at 0, 0, both of them. And so if I go left and right 3, because that's what that number tells me, and then up and down 3, it's going to be a circle with radius 3. And when I look over here, that 9 is our r squared, and so we have the radius is 3. They're actually the same graph. So it's just that an ellipse is really like a special, or sorry, not an ellipse, but the circle is a special ellipse where you go the same distance in all directions. An ellipse, when we say that, it's normally stretched out in one way. So those are all the differences and similarities that I see. You might see a few more, but that's what I saw. So that's it.